Hello everybody, my name is Drew Pikey and this is my final presentation for optimization. My project focuses on moving out of my apartment and transporting my belongings to a new apartment. I want to optimize exactly what items I should bring with me versus what items I should buy in my new location. Along with this, I want to optimize exactly how many vehicles I should use to make this trip. Essentially, this boils down to a 0-1 knapsack problem, with the vehicle being the sack. I utilize a fairly standard knapsack function along with a loop that optimizes the number of vehicles to bring to solve my problem. The inputs for this function are the items inside my house and the volume of the vehicles being used. Each of my possessions is assigned both a volume rating and a value rating, which are put in the volume and value input arrays, respectively. The sack used in this knapsack problem is the vehicle being used. The vehicle has a volume input called vehicle volume that can be assigned each time the function is run. For this pass, I assigned it to be 400 feet cubed. The function runs through a loop that compares the cost of replacing any remaining possessions with the cost of bringing extra vehicles to transport the leftover possessions. It outputs the optimal number of vehicles that would reduce the cost. Ideally, this function will optimize a combination of different size vehicles. My problem makes a couple of assumptions in order to simplify it. For one, the function treats all the items as bags of water, meaning there is a constant volume and flexible geometry. This means the items can be packed into the vehicle without geometric considerations. To counter this, each item is assumed a box shape and given a volume that was an overestimate of the actual volume. This, along with the fact that many of the items have empty space that can be utilized for packing, should balance out all of the approximations that I've made to an extent. My function outputs the value of the goods that are loaded into all of the trucks used, an array of all the items that should be brought, with 1 denoting bringing the item and 0 denoting leaving the item, the cost to replace all of the items left behind, and lastly, the optimal number of additional vehicles that I will use. For my final version, I would like to make a couple more improvements. Firstly, I want to add a range of vehicles with different vehicle volumes to be used and find the optimal combination of these vehicles. Secondly, I want to further take the geometry of these items into consideration. This could be done either using a packing factor to weigh against the volumes for the items or by assigning the items into types or bins. Each of the vehicles could hold only so many types of each item, which would give the closer geometric approximation for my assumptions. Beyond my simple moving problem, there are other applications to similar packing optimization problems. Industrial transportation companies can use a similar function to optimize which items to transport when, based on cost factors associated with not transporting the item. Along with this, moving service companies could use the same algorithm to move people's belongings in the most efficient way possible. They could assign commonly found items with a standard volume and packing factor, and quickly choose the optimal number of vehicles to use. Thank you.